Okay, the first problem, we're going to convert this first starting from degrees, minutes, seconds, and going to just degrees. So keep in mind that 1 degree is equal to 60 minutes, and also 1 minute is equal to 60 seconds. So those are the conversions we're going to use. So what you want to do is you want to start with this seconds, this 35 seconds, and you want to multiply it by the conversion between seconds and minutes. So you're going to multiply by 1 minute over 60 seconds so that these cancel. That gives me 0.583 repeating minutes. Now I can add that to the existing minutes, the 51 minutes. Now I have 51.583 repeating minutes. Now I want to convert those minutes to degrees. So I'm going to take 1 degree divided by 60 minutes so that the minutes cancel, and that gives me just degrees. And that gives me about 0.58972 repeating degrees. So I can add that to the existing degrees that I have for 19, and I get 19.5 or 85972 repeating. Now I can also do that in the calculator. It's actually quite a bit easier in the calculator. I can do 19, go to second angle degrees, and then type in 51, go back to second angle, and hit the second one for minutes, and then do 35 seconds. The seconds is right here by the plus sign, so alpha plus gives you the seconds. And there's my 19.587 repeating, which is exactly what we got here. So you can do the exact same thing for this now, but this one's trickier because now we're going from degrees to degrees minutes second. We would first take the 0.293 degrees multiplied by 60 minutes over 1 degree so the degrees cancel. That would give us this in minutes, which would about 17.583. So then we'd have 85 degrees 17 minutes because this is minutes, and then we could take this decimal right here and now convert just that decimal to seconds by doing 60 seconds is equivalent to 1 minute. So the minutes would cancel on this, and I'm doing just the decimal here, which gives me 35 seconds. So there's my answer. And once again, I can do this in the calculator pretty easily. If I plug this into the calculator and I just go to second angle and do the arrow degrees, minutes, seconds, which is 4, it converts it for me. It gives me the same thing, 85 degrees, 17 minutes, 35 seconds, which is what we got here. Okay, so for the next problem, I'm just going to do one of these, and I'll explain it really clearly and then let you hopefully use that process to find the rest of them. So for the first one, it says that this angle, 5 pi over 3, is found in what quadrant? Well, I'm going to stick with fractions first. So I'm going to take this 5 over 3. So I'm going to divide 3 into 5. And if I do that, it goes in one time. And if you follow through, you get a remainder of 2, just like our long division, or like what you did in elementary school. So what that means is I can rewrite 5/3 as 1 2/3. So what it really is 1 2/3 pi, which I could write as pi plus 2/3 pi. I think that helps because when you're looking at the unit circle now, you know pi is here, so that means we're going around 1 pi, and then we have another 2/3 of a pi. Now 2/3 of a pi, as we know, is break this into 3 equal parts, 1, 2, 3. Now from this point, and you're going 1, 2, so there's 2/3 of another full 180 or pi. So it takes you to right here. So we're looking at the fourth quadrant, and we would say that fourth quadrant. Now this also works with decimals. So I could do 5/3 in my calculator and find out that's 1.6 repeating. So it's 1.6 repeating pi, which we know is, once again, that's 1 plus 0.6 repeating pi. So what that means is we're going around 1 pi, right? If you could write this as pi plus 0.6 repeating pi, just like we did before with fractions. So you're going around pi, and you're going around another 0.67 pi, which is about right here in the fourth quadrant. So whether you like decimals, whether you like fractions, you want to be able to use your number sense to figure out where that number is in terms of the unit circle, because this is pi and this is 2 pi. So as you go around, it's 1 pi, 2 pi, 3 pi, and so on. So hopefully that helps a little bit. Okay, the next problem, I've showed you how to take an angle that's in degrees, minutes, seconds, and convert it to degrees. To do that, you just enter that in your calculator using the second angle notations here. And then for the seconds, you want to make sure that you use this down here, the alpha plus. Once you get that, you hit enter, and you get your decimal, which they're looking for the first part. So now to take that and convert it to radians, all we need to do is multiply by pi over 180 degrees so that the degrees will cancel, and we'll be in radians because this is actually pi radians over 180 degrees. And if we do that, we can add a pi on here, or in your calculator, if you just want to multiply by pi and give that decimal, you just take that answer and multiply it by second pi. And we get this answer here. which I'm not sure how many decimals you need, but do at least 3. Okay, the next problem wants us to find out if these angles are right, acute, or obtuse. So, just look at these on the unit circle. Obviously, 90 is right. That's right here. 60 degrees is right here, which we know is acute. 130 is 50 degrees less than 180, so it's somewhere over here, which we know is obtuse. 1 radian is the angle that you get when the arc length matches the radius. And the reason why is because this is our arc length relationship between arc length S, radius R, and theta, which is in radians. That's important. It's on our formula sheet. So when you have 1 radian, you can see that that means arc length equals radius. So what 1 radian is it's when this radius right here equals the length of this arc length right there. And that happens obviously in the first quadrant. You also know that, this is pi right here, which is 3.14-ish. So 1 radian is, about a third of that, somewhere over here. So that's an acute angle. And then 2 radians, is, that's 3.14, so 2 must be over here somewhere. And that's obtuse. And then pi over 2, if this is pi over 2 is exactly 90 degrees, which is also in your unit circle. So that'd be a right angle. Okay, the next problem says, suppose you have an isosceles right triangle. So the first thing you want to do is draw an isosceles right triangle, like this one here. Now, we know these angles then have to be 45 if this is 90 and these two angles are equal. So now we're looking at this angle, which is what they wanted, 45 degrees here. The ones that are equal at the bottom. Now, if we convert that to radians, we have 45 degrees, and we're going to multiply that by pi over 180. The degrees cancel. 45 goes into 184 times. That turns into pi over 4, which is a value on our unit circle. So we enter in pi over 4 using p to denote pi. Next problem is another conversion one. We're taking 80 degrees. We're going to multiply by pi over 180. That's how we convert. And we can simplify this. 20 goes into 84 times, and 20 goes 189 times. So it's going to be 4 pi over 9 if you want to simplify it. But that there is p for pi. And then to go the other way around, we take this pi over 5 right here and multiply by 180 over pi the other way around, so the pi's cancel. And then 180 divided by 5 just gives you 36 degrees. Okay, the next one wants to find a coterminal angle between 0 and 360 that's equal to 526. So 526 is really equal to 360 plus 166. What that means is this angle goes around once, you go all the way around once, and then you go back another 166, so you're somewhere over here. Well, we can simply just subtract that 360 to get back to the same angle over here, so just subtract this 360 from both sides, and you get 166, which is the angle that they're looking for there. That's coterminal. Same location, same direction, but actually a different angle. Okay, we've talked about this again. Using S equals R theta, if we have a circle of radius 5 miles and the arc subtends an angle of 1 radians, if this is 1 radians, then arc length equals radius, so we'd have an arc length of 5 miles. Okay, next problem I like to do with decimals, it's up to you, but this is 0.8 pi if you convert it, and this is 2.8 pi. So I can clearly see that I've added 2 to this one. So therefore, yes, they're coterminal. One of these is 2 pi greater 2 pi to get to this one. Okay, the next problem wants us to find the area of the sector for these problems here. Keep in mind this is radians. This is radians, but this is degrees. So be careful about that. But what I like to do is a proportion. I like to take the angle 2.369, divide it by the total, which is 2 pi radians in a circle. And that's got to equal the area we're looking for, the small area divided by the total area, which is pi r squared. So small angle over total angle equals small area over total area. Now the radius they gave us in the problem was 3.9. So if you plug that in and solve, get about 18.016. Now, you do the same thing for the next one, but the next one you got to use degrees, the last one here. So make sure that the degree angle you put up here, right here, has to be over 360 now, because you're in degrees. So be careful about that. Next problem's easy. Then just, obviously take the biggest one, which is my first one's the biggest if you convert. This is my second biggest and my third one if you convert them all to degrees. And then the last problem, your chance of receiving a given grade, an A, then you take the area for an A, which is 18.016, divided by the total area pi r squared. So it'd be 3.9 squared. If you do that, you'll get your chance of winning an A or getting an A. Be careful with your parentheses, but if you do it right, you should get about 37.7%. And also be careful about rounding when you enter this in. Next problem wants to find the distance the Earth travels around the Sun. So let's assume a circular orbit. It's actually elliptical, but assume circular. We're going to use S equals R theta then for this. And to find S, the arc length around, which is what we're looking for, we use the radius, which is 93 million miles, times the angle. Now the angle is 1/365th of a full 2 pi. That's important right there. You have to make sure you're in radians there. If you do that, you get an arc length of about 1.6 million miles. So they want million miles right here, so make sure you move the decimal place back 6 to get 1.6 right there. Last problem wants to find the arc that subtends an angle of 5 minutes. So S equals R theta. Radius is this. The theta, though, we have to convert this to radians. So I'm going to convert that for you. So we're going to divide by 60 to get the minutes to cancel, and then times by pi over 180 to get it into radians. Gives us an angle of about 0.00145. I didn't round that. I multiplied that in my calculator and got an answer right here.